Hello everyone, welcome to Royal Tutor Online platform. Um, Today we continue the topic we started earlier, laws of logarithm. If you have not seen the video, I will advise you see the video before you watch this so that you can comprehend with whatever we are doing. Also click on the subscription button so that you always get notification whenever we post new videos. So in the previous video I mentioned that I'm going to give us about 9 laws for logarithm, and I mentioned from law 1 to law 4 in the previous video. Today I want to work on law 5 from law 5 to law 9. That's 5, 6, 7, 8, and 9. Let's go. Okay. So law 5. Law 5. Law 5 says that whenever you have a logarithm like this, if you have log a raised power n base b, forget I mentioned what base is in the first video. So log a raised power n base b, it is the same thing as sending this power to the back. This is an index function. Then this index function, the power can be sent to the back to be n log a base b. So that means if we have log 8 base 10, it will be the same thing as having log 2 raised power 3 base 10, which you can send the 3 back based on this log to have 3 log 2 base 10. Log 2 is 0.3010, so this is going to give us 0.9030, which is the same thing as what log 8 is. Okay, what if the power is not here? What if the power is here? So if the power is not here, the power is here. This is just an example. That would be log 6. So you have log a base b raised power n. Yes, let's say it's something like this. What do we do? Okay, you transfer this power to the back, but instead of it standing above, it's going to be under a fraction. It's going to be 1 over n log a base b. Whenever it is the base that is carrying the power, by the time it comes here, it is the reciprocal of the power that will be at the back of the logarithm. E.g., if you have log 2 base 8, you want to simplify log 2 base 8, all you need to do is just have log 2, and then 8 can be written as 2 raised to power 3. If 8 is written as 2 raised to power 3, then you can have it as 1 over 3 log 2 base 2. So we said it earlier. We said it in our previous video when we talked about the law, the third law, which is law 3, that whenever you have log a base a is equal to 1. So this is going to be 1 over 3 into bracket 1, which is going to be 1 over 3. Okay, so whenever you have it, the power at the base, all you need to do is to do the reciprocal here. That is 1 over n, not n, 1 over n. But if the power is for the number itself, it becomes n. So let's go to law 7. Law 7 is a very interesting one. It says that whenever you have log a base b, it is the same thing as log a base n over log b base n. So whenever you have log a base b, you can split it into 2 logarithms standing on themselves, but the logarithm must be of the same base. So if you have log a base b, you can split it to log a base n over log b base n. For example, let's say we have we can even use it for this log 2. The example for this, e.g., log 2 base 8. Let's say we don't want to use this method, we want to use the method for log 7. All you need to do is to split it to something you can handle. Okay, let's say you have log 2 base 10 over log 8 base 10. You can split it to whatever base you want, just that they have to be the same. So this can be log 2 to base 10 over log 8 to base 10. We know that log 2 is equal to 0.3010. And from what we have here, log 8 to base 10 can be written as 3 into bracket 0.3010. So when this cancels themselves, you have 1 over 3 as the answer. Okay, so you can decide to split, you can decide not to split, depends on whatever you want to do. There's this law now that is very interesting, which is law 9. Law 8 rather. Law 8 is very interesting. It's just a direct product of law 7. Yes, it's law 8. It says that we have log A base B. It is the same thing as 1 over log B base A. Yes, let us prove it. Let's prove it. Left hand side, you have your right hand side here. Okay, so your left hand side is written as log A base B. From what we learned, from log 7, we can rewrite this one to be log A base n over log B base n. That is from a product of log 7. Log A base B can be written as log A base n over log B base n, of which we can decide to write it as 1 over log B base n over log A base n. Depending on what we are doing, you can decide to bring this one down. 1 divided by this is still going to give us log A base n over log B base n. So if you continue that, you see that you can return this one to back to something like this to have 1 over log B base A. They are of the same base, you can shrink them up. So this is the same thing as the right hand side. So we have that our left hand side is equal to right hand side. Yes, that's true. That's true. Since we can split this one here, because when you have a 1/3, it is the same thing as 1/1/3. I mean, sorry, the same thing as 1/3/1. Let me make another example. 2/3. When you have 2/3, the same thing as 1/3/2. Okay. When you have 4/5, it's the same thing as 1/5/4. So when you have log A base n over log B base n, it's the same thing as 1 over log B base n over log A base n. So these two can come together based on this law and give us log B base A, which is what we have on the right hand side. So lastly, the last law, this is just like kicking a ball. Law 9. Law 9 is like kicking a ball. If log A base B is equals to n, then A is equal to B raised to power n. This can be considered also as anti-logarithm. Yes, it can be considered as anti-logarithm. It's just like kicking a ball. Logarithm can kick B to go and carry n. So you have log A base B equals to n. If you have this, then you can say that your A is equal to B raised to power n. For example, if we have log 100 base 10, we know that if we solve this one using the previous knowledge of logarithm that we have, so we are going to be having 10 raised to power 2, then we can send the 2 backward. If you send the 2 backward, it becomes 2 log 10 base 10. 2 log 10 base 10. So we know that from log 3 that log 10 base 10 is 1. This is 2 in the bracket 1, which is equal to 2. So we can say that log 100 to base 10 is equal to 2. So if log 100 to base 10 is equal to 2, it implies that 100 should be equal to 10 raised to power 2. Is that true? Yes, it is true. If you do 10 raised to power 2, it is equal to 100. Okay? So they can set the question in any form. They can say log P to base 10 now is equal to 2. Find P. So you know that P is 100, definitely. So you can just kick it up to have P is equal to 10 raised to power 2. And what's 10 raised to power 2? 10 multiplied by 10. So P is equal to 100. So we have the answer. So far, we've treated 9 laws of logarithm. And don't forget, I told you from the beginning that all these things they are relative to whoever is teaching you. Some people can come up with 10 laws, some people can come up with more than that, some people can come up with less than that. It doesn't change the fact that all these things are just to help us to make the work easier for us whenever we are doing with logarithm. Don't forget that you have to subscribe so that you get notification whenever we post new video. And then I want you to click on the like button if you find this lesson informative. Also, I expect your feedback through the comment box. Thank you very much. See you next time.